all you Gretas and Shutezcats out there. Welcome to APES Notes Unit 4, Section 5, Global Wind Patterns. So a silly cartoon to start you guys off. He's not a big fan because he's a wind turbine. Alrighty, so air, we have four main properties that are going to determine air circulation patterns. Our first one is air density. So the less dense you are as you go up, the warmer air is going to rise. So if you've ever been like way above sea level, I've been out in Utah and the air is much, much thinner there. Our first mile hike into the mountains, we went up 1,000 feet in altitude while wearing 70-pound packs on our back. So super good workout. So at sea level, you've got the air is much closer together and it's just less dense as it goes up. So it's much harder to breathe. This is why athletes will often train at higher altitudes, because if they can breathe well, they can get used to breathing well here. Once they go back down to this, it's like superpowers. Second one is water vapor capacity. Warm air has a much higher water vapor capacity. Think when it's hot and humid in the summertime. So if we're 90 degrees, we have a capacity of this. If we're 40 degrees, that's why when they talk about it being too cold to snow, it's because there's not enough moisture in the air for snow to even happen. So the colder you get, it's actually too cold to snow. Adiabatic, heating and cooling. So this is a response to change in pressure. So as air rises, it's a lower pressure. So the volume is going to expand about whatever it is. And then as it cools, it's going to go back down. So it'll contract. So expansion and rising, and expansion and cooling as you go up, and then it'll actually sink and contract and heat back down. So there's that. And then we have what is called latent heat release. And this is the release of energy as heat when water vapor condenses into precipitation in clouds. So when you go from ice to either liquid or vapor through melting or sublimation, you're going to take heat energy from the environment. When vapor either condenses down into a liquid or deposits down into ice, heat is released into the environment. So these are the four factors that are going to affect things. Your next little graph, here are some pictures. So we have in low pressure, we have cool, dry air up. That's going to fall and gets compressed and warms up. So you now have warm, dry air. And then it's going to flow towards and be in higher pressure. It's going to flow towards this low pressure, pick up moisture and heat. Moist surface is warmed by the sun, and now we have hot, wet air, which is going to rise, expand, and cool. We have condensation and precipitation up at the high pressure. We have a lot of heat released that radiates to space, and then we start all over again. And so here's kind of a system of what goes on. There are two videos that I'm going to post on Canvas for you to watch to help these things make a little bit more sense, but I'm going to give you just some basics now. So we have warm air rising as it moves towards the poles. So the air goes up and then comes back down, and then we've got these cells, which is going to actually be in the next section. But we have what are called the northeast and southeast trades. So on your paper, you should draw the Earth and show the northeast and southeast trades, how they go, and then the westerlies and how they are pointed in the opposite direction. So we've got some pointing towards the equator and then pointing away from the equator, and we don't go straight because of what I'm going to get to in just a second. Understand that the solar energy is the highest input at the equator. It's most directly. So the reason that it's hotter at the equator isn't because the Earth is so much closer to the sun there. It's because of the angle. So it's getting a more direct line from the sun. Imagine me shining a flashlight directly in your eyes versus from an angle. So direct solar energy here versus much more indirect at the poles, which is why it is colder there. So I would pause and draw these arrows in. And then you want to, and feel free to only put this on one side of your Earth. You want to draw in the arrows for the convection cells. And there's two videos I'm going to post that talk about both of these things in better detail than I am, and they do a better job, so please watch those. Understand the Hadley cells are going to go up and away from the equator. The Ferrel cells are in the middle, and then the polar cells are on top. So There we go. Remember the order, remember the name, remember how these things go. So you're going up, over, back down. So you can remember these are coming back down, and then you're once again going to go along, get heated, go up, and then come back around, and these are going to circulate that way as well. You can see that based off of this, this is how the biomes are made up. So you have your polar areas, you have your temperate areas, you have your really dry areas, and then you have your wet areas, your tropical areas. And as all this water the air is rising, it's going to dump that water. And so this is why you have most of your rainforest right around here. And then it's going to come back down and be drier, and that's where you get your deserts. And hey, look, there we are. And then a couple other little areas. The Coriolis effect. So if you think of a ball spinning, the middle of the ball is larger than the top part of the ball. So if I was spinning a ball and you were to draw a line straight up, as it was spinning, it's not going to go straight. It's going to curve. So we have this deflection of objects, or wind or water, to the right in the northern hemisphere and to the left in the southern hemisphere. And once again, watch the video. They do a more detailed job of explaining this. Then we have ocean gyres. This is a formation due to both rotation and wind patterns. So the sun controls the wind and the water, and that is going to control heat. The heat is going to control everything. Hot air and hot water rises, cold air and cold water sinks. So everything comes back to the sun. These are massive circular current systems. We've got 5 major ones you can see, and they impact temperature, salinity, and nutrient distribution globally, which is kind of cool. So when you see them like this, your upwellings, you're going to have a lot more minerals and materials being deposited here. In the North Pacific area, this is where the Great Pacific Trash is, the trash heap. It's about twice the size of Texas right now. So we'll talk about that in a later unit, but this is where it is, so you can get a visual of that. And you have survived yet another round of notes. So before I go, I want to let each and every one of you know that you are good enough, you are smart enough, and people do like you. And in case I don't see you, good afternoon, good evening, and good God, do your homework.